Today we will discuss application of matrix and determinant. Matrix and determinant can be used, number one, in solving system of linear equation, and secondly, it is used for checking consistency of system of linear equation. Now, what is a linear equation? An equation of degree 1 which is of the form ax plus b is equal to 0, a not equal to 0 is called a linear equation in a one variable, and of the form ax plus by plus c is equal to 0, a and both not equal to 0 is linear equation in two variables. For to check the consistency of system of linear equations, first you know any linear equation and two variable always represent a straight line, and pair of linear equation will represent two lines on the graph. If you plot two lines, either these two lines will intersect, or secondly, two lines may be parallel, and lastly, the two lines coincide with each other. These pair of lines are called intersecting lines. These are parallel lines, and these are coincident lines. Both the lines are overlapping with each other. They have same set of solutions. Now we'll see what will be the consistent system if two lines intersect at a point. We get a unique solution, and this system is said to be consistent system. Secondly, these two lines are parallel, they do not intersect. So in this case, in the case of parallel lines, we will get no solution, and the system is said to be inconsistent system. And lastly, the two lines are overlapping with each other. We are getting so many solutions. So we'll write infinite many solutions. And in the case of infinite solution, it is also have a solution, so many solutions, therefore it is consistent. Hence, if you have one solution or if you have so many solutions, the both systems are said to be consistent. If you are not getting any solution, then that system is said to be inconsistent. Solution of system of linear equation using inverse of the matrix, and this method is called matrix method. Sometimes question is asked, using matrices solve the system of equation. This is same as a matrix method. If you have an equation a1x plus b1y is equal to c1, a2x plus b2y is equal to c2. Linear pair of linear equation in two variables. Or you have a1x b1y c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. In both the cases, you will write these equations are of the form Ax is equal to B. Here A is A1, B1, A2, B2, and X is variables involved, X comma Y, and B is C1, C2. This is constant. And here, what is A? It is A1, B1, C1, A2, B2, C2, A3, B3, C3, and variables involved are X, Y, and Z, and constants are D1, D2. Here, A is a coefficient matrix, X is a variable matrix, and B is a constant matrix in both the cases. Now you will calculate determinant of A. If determinant A is not equal to 0, your equation has unique solution. And if determinant A is equal to 0, then equation has either no solution or infinite solution. How will you calculate? First of all, you will calculate adjoint A. If you multiply adjoint A with B, either it is equal to 0 or it is not equal to 0. If adjoint A into B is not equal to 0, equation has no solution. And adjoint A into B is equal to 0, then equation has infinite many solution. Infinite solution. And how will you calculate unique solution? For calculating unique solution, you know the equation are of the form Ax is equal to B. If you multiply both sides by A inverse into B. A inverse into A is I. And what is I into X? It is X. Hence, X is equal to A inverse into B. And what is A inverse? A inverse is adjoint A over determinant A. Now, in the case of no solution, adjoint A into B is not equal to 0. It is not equal to 0. But determinant is 0. Then equation has no solution. But in the case second, adjoint A into B is equal to 0. And determinant A is also 0, then it has infinite solution. Here you will calculate adjoint A. Then you will calculate A inverse. What is A inverse? It is adjoint A over determinant A. And what is X? You will calculate X by using X is equal to A inverse into B. This whole method is called matrix method. Solve the equation by matrix method. First of all, you will write these equations are of the form Ax is equal to B. What is A? It is a coefficient matrix. It is 5, 2, 3, 2. And X is variable matrix. Variables involved are X, Y. And what is B? It is a constant matrix. It is 3, 5. Now you will calculate A determinant. Determinant A is 5 to the 10 minus 6 is 4, and it is not equal to 0. In case determinant A is not equal to 0, equation has unique solution. For unique solution, first of all you will calculate adjoint of A. For calculating adjoint, you will find the cofactors of each of the elements. Minus 1 raised to 1 plus 1, and it is 2. A1, 2, minus 1 raised to power 1 plus 2 is 3, that is minus 3. A to 1 is minus 1 raised to power 2 plus 1 minus 2, it is minus 2. A to 2 minus 1 raised to power 2 plus 2 minus 5, it is 5. What is adjoint A? It is transpose of cofactors. You will write the cofactor at the proper places and you will calculate the transpose of the factor. Now 2 minus 3 minus 2 and 5 whole transpose. You interchange rows and column and here it is adjoint A. And what is A inverse? A inverse is adjoint A over determinant A. Adjoint A is, and what is determinant A? It is 4. 1 by 4 into this. And for calculating the value of the variable, we use last x is equal to A inverse into B. And variable matrix was x into y, x over y. And A inverse is 1 by 4, 2 minus 2, minus 3 and 5. And B is constant matrix, it is 3 and 5. Now you multiply these two matrices, 3 2 is 6, minus 10, minus 9 plus 25. It is minus 4 and 16. Now multiplication of matrix by a scalar, it will be 1 by 4 into minus 4 minus 1, 1 by 4 into 16 is 4. Now you compare the two matrices, x is equal to minus 1, y is equal to 4. Right answer, as we have substituted the value in this equation. A linear equation in 3 variables में बिल्कुल सेम हम वैसे ही लिखेंगे. These equations are of the form ax is equal to b. What is a? It is 3 minus 2 3, 2 1 minus 1 and 4 minus 3 2. Variable matrix is, variables involved are x, y and z, and the constant matrix is 8 1 and 4. A will be minus 17 and A inverse will be given by this. ये दोनों आपने पिछली वीडियोस माइनर और कोफैक्टर और एडजॉइंट इनवर्स वाली वीडियोस में सेम इस मैट्रिक्स का मैंने डिटर्मिनेंट और इनवर्स निकालना उसमें बताया है. तो वो आपने वीडियो जरूर देखनी है, उसको दोबारा देखें रिवाइंड करके और वहां से देखें कि आप ए इनवर्स कैसे कैलकुलेट करते हैं. नाउ वी विल कम टू लास्ट स्टेप. x is equal to A inverse into B. X is a variable matrix. A inverse you have calculated minus 1 by 17, minus 8, minus 6, 9, minus 10, 1, 7. And what is the constant matrix B? It is 8, 1. Now you will multiply this minus 8, minus 5, minus 4, minus 64, minus 6 plus 36. It is minus 80 plus 1 plus 28. Now you will calculate this. It will be minus 17, minus 34 and minus 51. You multiply minus 1 by 17 with this. You will get 1, it is 2 and 3. Here was x, y, z. The value of employees, x is equal to 1, y is equal to 2 and z is equal to 3. अब ये हमने इक्वेशंस को सॉल्व किया है यूजिंग मैट्रिक्स मेथड. तो मैट्रिक्स मेथड से x, y, z की वैल्यू आ गई 1, 2 and 3. तो ये सब्स्टिट्यूट करके देख लीजिए किसी एक इक्वेशन में, तो आपको पता लग जाएगा इसका आंसर ठीक है.